Hello guys, my name is Engineer Holiday. You are welcome to another section of my video. And this time around, we are going to be looking at a compound microscope. And I believe that you should understand that a compound microscope is an optical instrument. If you don't know, it's an optical instrument that is used to measure tiny objects. They are optical instruments used to observing tiny objects. So what about a compound? What brought about a compound microscope? No, don't forget that we talked about a simple microscope, and in a simple microscope, the resolution and the magnification is very low compared to a compound microscope. So a compound microscope is used for high resolution or to highly magnify an image, a tiny image or a tiny object rather. So in the total definition of a compound microscope, so a compound what? A compound microscope is an optical instrument, that is highly magnified or highly used, or that is used, let me put it that way, that is used to magnify or highly magnify what? Highly magnify tiny objects. Tiny objects. Sorry, let me change the tiny objects. So these are what? Compound microscope. There is an optical instrument that is used to highly magnify tiny objects. So it's this magnification now that we're talking about. Don't forget that the simple microscope cannot be compared to compound microscope in that a compound microscope gives a high resolution or high magnification compared to or a higher magnification compared to what a simple microscope. Now let us do a sketch of a simple microscope and let's see how it goes. Let's see how it goes. We have two lenses. Don't forget, a compound microscope uses two lenses. Let me make a rough sketch. This is what a rough diagram of a compound microscope. Now, having done that, you are going to have your object between what? Let's say this is a focal length, or this is objective lens, and this is what? The eyepiece lens. We call it the ocular lens. That is another name they call it. So, if you place an object, let's say this is the what? The F naught. Then let's have two F naught here. And let me have an object placed here. This object is placed here and it will what? Move this way. Let's say this is F naught. These two F naught. So it will pass like this. Then this particular one, there will be a what? The optical center. Now this optical center here will be now the what? The ray of light parallel to the optical center. I mean, parallel to the principal axis rather. This is it. This is the optical center. So we have this point, this optical center. There will be a ray of light that will pass through that point. Okay. So F. So, okay. So this is the where the image will form. So the image will form there. So this is the object. So now this is, let's indicate this optical center of the second of the eyepiece lens, and so this one will go like this. Then one will go through the optical center of. Okay. So this is what the lens, and this is the mirror. Now in this case now, we have been able to do a sketch of what a compound microscope. The eye will be placed here. Is where the eye will be placed. Eye will be placed there. This is the image that is formed, and this is the optical center of the second lens, which is the eyepiece lens. Now, what can we bring out from this what? This compound microscope. What can we bring out from this what? Compound what? Microscope diagram. Now, it uses what? Two lenses. It what? Uses what? Two what? Convex lenses or converging lenses. The first converging lenses, the first lens is lens 1, and this lens 2. Because in the diagram we're going to be seeing everything. This lens 1, the lens 1 is an objective lens. It's an objective lens. So the lens 1 is an objective lens. Lens with focal length f0. So the focal length of this one is f0, the focal length. Then, and the second lens is what? The second lens is eyepiece lens, or what we call ocular lens. Eyepiece lens with focal length fe. That is focal length fe. Now in this diagram so that we have drawn, also notice that one of the lens is acting as a magnifying glass, which of them? Don't forget the first image. This is the object. This is the image of the what? The objective lens. This objective lens, let me put it here so that we can see it well. This objective lens. So the first image of this what lens is what we call the first image of this objective lens is what will now form, or the image of this object is this, of the lens, objective lens is this one. Now this one we now take, that is from here to this place is what we call the image distance of the objective lens. Why here? Now don't forget that this image will fall inside the what? The eyepiece focal length. So this is the eyepiece focal length. Let me put it that way. So from here to this place is what? Objective object distance of the eyepiece lens. Object distance of the eyepiece lens, UE. So UE means object distance of the eyepiece lens. So from here to this place is the image distance of the objective lens. That's why I call it V subscript O. Now, if you understand, this place now from here to this place is the object distance of the what? Of the objective lens. Why this one is object distance of the eyepiece lens. This is image distance. Then from here to this place is what we call least distance of what? Distinct vision. Least distance of distinct vision. We call it a what? LDDV. So from here to this place is what? LDDV. Now, don't forget the two lenses have a short focal length. Don't forget the two lenses have a short focal length. So that means with both, with both, with both having what? A short what? Focal length. Focal length. Let's take note of that. So that means this is two convex lenses or two converging lenses. The first lens is what? The objective lens, while with focal length f naught, and the second lens is what? Is the eyepiece lens with focal length f naught, fe, with both having a what? A short what? A short focal length. Although fe is greater than f naught, so the focal length of the eyepiece lens, which you also call, I told you, is called the ocular lens. You see me? Is greater than the what? Than the objective lens focal length. The eyepiece focal length is higher than objective focal length. You can actually use these acronyms. Moses. So Moses, what does Moses mean? It means that what? Microscope objective length is shorter, eyepiece lens is shorter. That is to say, Moses is a shortcut to remember. Say after me, Moses. Now, Moses is what? A shortcut, is a name of a person that put in an acronym form to remember that all microscope, M means microscope. Microscope. Objective length is for what? O. S is what? Shorter. Then eyepiece length, eyepiece length shorter. So that means that even though the eyepiece focal length is higher than the objective focal length, the two of them are still short. They are still short focal length, my dear. Because why? Now, even don't forget that they are used, optical instruments, that microscope generally are used for magnifying image. They are basically used for what? Magnifying image. But in this case now, there are two things that happen here. The principle works in a way that the image produced by the objective lens is now used as the object by the eyepiece lens. That is how it works. Now, which one is called the magnifying glass? The eyepiece lens. The eyepiece lens is known as the magnifying glass. Magnifying glass. So the eyepiece lens is what we call the magnifying glass. The eyepiece lens is called what? The magnifying glass. Don't forget that. Very, very important. So when we say eyepiece lens, it's called the magnifying glass. So let me clear this part. We have written this part. So eyepiece lens is called what? Magnifying glass. So if you now understand that the eyepiece lens is called magnifying glass, therefore we can now go ahead to what to talk about something. Now the image formed by the objective lens is the image formed, the image formed by the what? The objective lens is real, inverted, and what? Enlarge or magnify. The image produced by a what? An objective lens. That means the image of this object is enlarged, inverted, and what? Magnify or enlarge. Inverted, re-inverted, and what? Enlarge. That means the shortcut can be what? RIE or RIM, as the case may be, anyone. Now, but what about the final image? Now, don't forget that the eye can eye piece is it has to what? To see the image. Why what? Objective lens is to see the object, though the two of them are working together. The final image produced by these two lenses, the final image produced by these two lenses is what we call real, no, inverted, virtual, and magnified. So the final image, or let me say the image produced by the produced by the eyepiece lens is erect to the eye, is erect, virtual, and what? Magnify. But when we talk about the final image, that means with respect to this eye, if this one is the object of this eyepiece, the object and the image, if you check the two of them, they are if this one is the object, that means it's also erect to the eye. But if with respect to the what? To the object, that's when they mention final image, it means with respect to the what? To the eye, to the object, the real object itself. So the final image of the object in a compound microscope is virtual, inverted, and magnified. This is a very, very sensitive question. And don't forget, if they ask you in the exam, see, what is the final image produced? Describe the what? The image. You just tell them it is what? Virtual, inverted, and what? Magnified. That means virtual, inverted, and magnified. Vim. So vim is what? Is the final image produced. What is the image produced by the object? It is what? Real, inverted, and enlarged. Now let's go to the final part of this. Now don't forget this setup, that the final image is at the least distance of what? 25, least distance of distinct vision of 25 centimeters from this place to this place. So in that case now, let us know that I told you that this one is the magnifying glass, because it's the one that magnifies the image like this. Is the one that will magnify the final image. That means this object, you will not want to what to magnify it. So this one, eyepiece lens is acting as a magnifying glass in a compound microscope, and is the one to see the object, the image, while the objective lens is to view the object. Now, another thing again we have to understand here is that during what in compound microscope, which is used for magnifying what a tiny image, it means that for an image to be magnified, it has to be what? Abnormal adjustment. So that means that abnormal adjustment of a compound microscope, it produces a virtual, inverted, and magnified. A virtual, inverted, and magnified. A virtual, inverted, and magnified. Now, let me generate the formula. Let's generate the formula of a compound microscope. Let's generate the formula of a compound microscope. So if I have the form 1 over f equal to 1 over u plus 1 over v, that's the formula for length. Now let's consider this one as the object distance. Object distance of the objective length, f naught. This one is f naught, this fe. Now let's consider that this one is what? Image distance of the objective length. So now let's see. So what do? Let us look for the magnification. So let's multiply all through by what? By v naught. Let's multiply all through by v naught. That equation. Let's multiply this equation by v naught. So what do you have? Plus what? This v naught over v naught. So what do we have? This one will cancel this one. So this one becomes what? M plus what? 1 equal to what? V naught over what? F naught. So this one now will come here. I would have it as what? V naught over F naught minus 1 equal to M naught. This M naught is magnification of what? Of the objective length. So this is it. Now, magnification of the eyepiece length now is equal to what? What is magnification of the eyepiece length? Now I want to have it as 1 over Fe equal to 1 over Ue plus 1 over Ve. This one is your Ve, which is also called D. So we can write it as D. But to the eyepiece, this D is minus sign. So why? Because the image is what? Virtual. So we have minus sign attached to this. To the eyepiece, the image is virtual. So I would have this at what? Multiply everything by D. I would have D over Fe equal to what? D over U minus 1. So D is an image. Don't forget, D is what? Image distance of the eyepiece. So if you want what? This one is magnification. This one just implies that D over Fe equal to, this one is magnification. So N of eyepiece minus 1. So final formula will now be what? Magnification of eyepiece will now be equal to what? D over Fe plus 1. So this is the what? The formula for that. Now I haven't done that, which is the formula for what? Now what I want to do now is we now combine the two of them together. The magnification of a compound microscope is what? Total magnification is equal to M naught times ME. You can still use this formula to do it. This is angle suspended by the image, final image. Then we can take this as what? Angle suspended by the what? By the object, alpha. So we can use this one also can be what? Tan beta over tan alpha. Which you, if you prove it, you are going to have the same answer there, but we don't have enough time to do that here. So what is magnification of the object, of the objective lens? You have solved for it, which is this one. What magnification of this? Magnification of what? Magnification of eyepiece lens. This is what magnification of the objective lens. So if you combine them, it's magnification of the objective lens. So if you combine the two of them now, we now have our general formula for what? Magnification of a compound microscope as what? V naught over F naught minus 1 into bracket what? G over Fe plus 1. So this is the what? The total magnification of the what? So we can also use this formula to get it. The tan of the what? The angle suspended by the final image to the what? To the, that means the ratio of angles final what? Angle suspended by the final image to the tan of what? Angle suspended by what? By the object. I said you can also get magnification by what? Taking what? The ratio of the tan of angle suspended by the final image to the ratio of tan of angle suspended by what? The object. You still get the same answer. And so what these are other way to solve it in a faster way or in a very fast way of getting it other. Now this one now we have gotten this particular distance to our normal adjustment. Now let us see a different case. Let's see a case 2. This one is not too common. Where the object is close to what? The object is close to the focal length. That means the object is close to the what? The focal length of the objective lens, and the image of the what? The object of the eyepiece lens is also close or exactly the same as what? As the focal length. That means that the image formed by this particular one, by this object, is at Fe. That means focal length of the eyepiece lens or close to the focal length of the eyepiece lens. What will happen to it? Now, if you have that, don't forget that let's assume that we now put this particular image here. What will happen is that the total length, look at what I'm saying. Let's say we have a rough sketch here. It's a rough sketch anyway. So let's say we have a rough sketch like this. Now let's say this particular one is at Fe. That's what I'm saying. Now the length here from here to this place is length L. Don't forget the length from here to this place is what? Is the length is UA, the object distance of the eyepiece lens and image distance of the objective lens. Object distance of the eyepiece lens and image distance of the objective lens. So that means that here will not be V naught plus what? V naught plus what? UE is equal to this. But in a case where that is, in a case, this one is at normal case now. Now, in a case where the eye is relaxed, where the image of this one form, this one is almost, the image is almost at F naught. Is almost at F naught. What will happen? What will happen? Now, what will happen is that we will now have from here to this place is V naught. From here to here, let's say is Fe. That means the total length will now be equal to what? V naught plus what? Fe. When the what? The eye relaxed. So at this point, the eye will what? Relaxed. Yeah. And for a particular eye to relax, it means that the image is what? At infinity. The final image is at infinity because here. And because the final image is what? At infinity now, it cannot accommodate such what? Particular image. So if you cannot accommodate such a particular image, so the focus will try to what? Adjust in a way that the eye will relax. The focus will now what? Be adjust in a way that the eye will now relax, because at that point the image is unaccommodative to the eye. So in that case now, our L is equal to V naught plus Fe. And if that is our length, total length, so that means that F of a V naught will now be what? What's our V naught? V naught will now be equal to what? Take this one here, will now be L minus Fe. And don't forget, this one can be called the length of tube of the compound microscope. It can be called the length of tube of the compound microscope. Now, in this case, that length is far greater than the what? The Fe. The length of the tube is very higher than, is far higher than the what? Or much more higher than the what? Than the focal length of the eyepiece lens. So in that case, this one is what? Approximately equal to what? L. Approximately equal to L. And that, don't forget, this is the image of the objective lens. The image of the objective lens is what? Inverted. And since it is inverted, the magnification M is equals to minus V naught over U naught. Minus V naught over U naught, which is the same thing as what? Now, I told you that at this point now, when the object is close to the focal length of the objective lens and is close to or exactly the same as the focal length of the eyepiece lens, that means image distance, object distance of the eyepiece lens is almost the same or exactly at what? Fe, focal length of the eyepiece lens. Now, what will happen is that the magnification of the objective lens is now what? Taking a new shape, which is what? Minus. I told you why minus is there, because it gives us an inverted image. Anytime you have an inverted image, it is negative. So minus what? L minus Fe over what is object distance? Now be what? F naught. Then this one will approximately equals to what? Minus L over F naught. That is for what? Magnification of what? Objective lens. What about magnification of eyepiece lens? Eyepiece lens is what? V E over what? U what? E. Don't forget that VE is equal to what? The distinct LDDV, which is least distance at distinct vision. So this one now will now be what? 25 cm. What about your UE? I told you your UE is equal to what? FE. So this is the magnification when the eye relaxed. When the what? Object is almost close to the what? Or is nearer to the what, focal length of the objective lens, or exactly at the focal length of the objective lens, which now resolve to what? To the what? The lens being positioned. So we position the lens, the eyepiece lens, in a way that the focal length of the eyepiece lens is exactly the same as what? As object or image or object distance of the eyepiece lens, or close to it. So if it happens like that, this is the magnification of such. So that is it. Now, if you now want to get the total magnification according to the what? To the analysis. So the total magnification will not be this times this. So total magnification will not be what? Minus L over F naught, which is this for the then times what? 25 cm or 25 over what? Fe. So our final magnification will be what? 25L over what? F naught Fe. So don't forget, L is the length of two of what? Of the compound microscope, or the length between the what? The distance between the two lenses, the converging lenses between the two of them can be so. Now, why is the minus sign? It is, you can, most of the times we ignore, it's commonly ignored. And the minus sign is just to show that the final image produced in a compound microscope, whether at this position where the eye relaxes, is what, even though the image is formed at infinity, is still what? Virtual, erect, inverted, and what? Magnify. Although the eye cannot, what, does not accommodate it. So even the what, the focus, the focal length of the lens now adjust in order to what, make the eye relax, to be comfortable. So in that case now, we say in this case now, and don't forget that when the eye relaxes, it means that it cannot accommodate the image. It does not what, it's unaccommodative. That is to say, the image cannot be seen by the eye, so it's now relaxed. So that is just that. So this minus sign, it shows that the image is what? The final image is what? Inverted. The final image is what? Virtual, inverted, and magnified. Virtual, inverted, and magnified. So don't forget that compound microscope have been discussed in this class. We have been going to what? Look at two cases at normal adjustment. Then we are going to look at compound microscope as an optical instrument that is what? That is used to highly magnify what? Tiny object. The magnification of the compound microscope is higher than a simple microscope. It resolves the limitation of a simple microscope. Don't forget, in our last class, I told you to go and look for something for me. So you type it. Now, in this class now, the question is, a compound microscope, does it have a high resolution compared to what? Simple microscope? Why is compound microscope preferable to simple microscope? You have to type that in the comment section. Number two now, please don't forget that also, what is the image produced by the what? By the objective lens of a compound microscope? Number four, what is the, I told number one, why is what? Compound microscope highly preferable to what? Simple microscope? Number two, why is that what? What is, okay, let me say, what is the difference between a compound microscope and a simple microscope? Number three, what is the, let me put it this way, how many what lenses are used in the two of them? Which of them? And what is the arrangement that will make the eye relax? All those things you can type them in the word. Then the last one, which is number four, is that if you are given a compound microscope, at what is the final image of the compound microscope? I'm not saying that the image produced by the eyepiece lens, the final image of the compound microscope. Thank you very much. God bless you for watching.